So what is concentrated solar power? It's a process by which solar light is concentrated onto a focal point with the use of mirrors and lenses in order to absorb the light's thermal energy.
When designing systems for this method, there are two main components: the collector, which harvests the radiation from a large area, and the receiver, which absorbs the radiation with a significantly smaller area. Using the same amount of radiation but with a smaller area allows us to increase intensity. However, this graph shows us the limits of these systems. Eta represents efficiency, and C represents the Carnot of the system. At a certain temperature, the efficiency starts to decrease, which implies that reaching high efficiency comes down to the materials and the makeup of the system.
And why is it useful? This technology has tons of benefits. Besides the creation of the physical products, concentrated solar power is carbon emission free. It is also a great way to use land, especially in areas with little water and high sun that wouldn't be useful for farming. There's also very little harm done to the land being used. Also, the sun's energy will still be reaching Earth in 1 billion years. The parabolic trough is the most common use of concentrated solar power, with 90% of current applications. It consists of a linear parabolic reflectors concentrating light onto the parabola's focal line.
Another application of concentrated solar power is the use of solar power towers, which consist of an array of reflectors that concentrate sunlight onto a receiver on the top of a tower. As you can see from the diagram, the reflectors are placed around the tower, and as the sunlight beams down onto the reflectors reflect the sunlight to the top of the towers. From the top of the towers, this energy is used to spin a turbine and therefore generate electricity. This way of concentrated solar power is the least efficient method at 17%. The final application of concentrated solar power that our group will be looking at is the Dish-Stirling method, which is a standalone parabolic trough reflector that concentrates the light onto a receiver at a focal point. It is the most efficient at 24%, and that is because light is being directly focused onto that focal point at the closest distance to the trough. Concentrated solar power financially is cheaper than photovoltaic power. It is also the same price as natural gas with less environmental cost. As you can see from the diagram, the cost of concentrated solar power has been decreasing and is expected to continue to decrease as new materials are thought of to create a more efficient system. As efficiency increases and the cost decreases, the application of this use is expected to increase in the future.
Although this is significantly better for the environment than the current popular energy sources, it still has its drawbacks. With such high intensity of sunlight, when organisms such as birds or insects are attracted to it, they will be severely burned. Not only that, there are no perfect materials that can function properly forever, so there will eventually be trash. The bottom line is, concentrated solar power takes sunlight and converts it to thermal energy. It eliminates most negative environmental effects of burning fossil fuels. It has comparable costs to natural gas and is generally less expensive than other solar energy technologies.